Hello everybody. Today we're going to take a look at reducing fractions, part of the reducing fractions module, converting fractions to decimals. This is 2.2f. So as always, there is a video here that you can watch provided by WAMAP, and I'm going to work through the problems here and give you some links to Khan Academy and practice worksheets to play with. Okay, so we're going to try and write 3/8 as a decimal. And then we have another one, write 11/16 as a decimal. If any of you work in construction or have worked in construction, this kind of conversion can be very important. So let's take a look at this. Let's go to my tablet. So I've got the problems written out here. We're writing 3/8 as a decimal. And the main thing to remember is any decimal can be written as a fraction, and any fraction can be written as a decimal. And the way we do that is we can read this as 3/8 or 3/8. And there's always implied division, that 8 is being divided into this 3. So if we just write that out that way, as 3 divided by 8, we can find a digital representation of this fraction, or decimal representation. So 8 won't go into 3, so what we have to do is add a decimal point here and put a mirror image of that up on here on the answer line. And we're going to add some trailing zeros. And you can put as many as you want here. Adding these zeros, 3.000 is no more or less than 3, so it's mathematically equivalent. But now we have a larger set of numbers to work with, and we can divide 8 into 30. So 8 goes into 3 0 times. Well, you can put a 0 there. Then we're going to look at the next two numbers as a single number. So 8 goes into 30. How many times? Well, 4 times would be 32, but 3 times should work. Will give us 24. 3 times 8 is 24. We write down the 4. And the 2 goes over here. And now we subtract 24 from 30 and continue. So we have to borrow 1 from the 3, leaving 2. 10 minus 4 is 6, and then 2 minus 2 is 0. So now we're going to try to divide 8 into this next number. We bring down the 0 that we added for free. And then we ask ourselves, how many times will 8 go into 60? So if you know your multiplication table, you can get from 8 times 8 would be 64, which is too high. But let's try 7. 7 times 8 is 56. That should work. And let's subtract that. Borrow 1 from the 6, leaving 5. Makes 10. 10 minus 6 is 4. And 5 minus 5 is 0. So you can write that here or not. Seem to have activated the eraser again. And then we bring down our last 0. And we divide 8. How many times will 8 go into 40? And the answer there is 5. And 5 times 8 is 40. So we have 0 remainder. So our answer is this decimal, 0.375. And if you work in a machine shop, you'll see a lot of these where you go from fractions to decimal and back again. And there is a way to convert this back to a fraction. This is read, one way to read this is 0.375. The other way to read this is 375 thousandths. And if you write that the way it's pronounced, 375 thousandths. If you factor this down, you will get 3/8. Should we do that real quickly? Just let's do. So let's see, 375. And this can be factored down, right? We can take out a 5. And how many times does 5 go into 375? Let's see, what would that be? What's 2 times 37.5? Anyone got it? Is that like 75? So I think we'll put 75 here. 5 times 75 should give us 375. And then 5 is prime. We can take a 5 out of the 75 and get 15. and then take a 5 out of the 15 and get 3. So our factorization here, prime factorization, is 5 times 5 times 5 times 3. And those are all prime numbers. So let's get a different color. And I'm going to write this is equal to 5 times 5 times 5 times 3. And then let's factor 1,000. So we're going to do prime factorization of 1,000. Let's put that up here. 1,000. Whoops. Can't get it that close. All right, we'll put it over here. 1,000. So let's take out, which do we take out? It doesn't matter what number you start with. You could start with, say, 10 and 100. And we'll take out primes out of 10. We get 2 and 5. I'm going to need to erase that, I think. See if I can trigger the erasure thing. There it is. All right, get rid of those little extra dots. And see if I can get back to where I was. Yes, okay. And we can take out a 5 out of 20, a 5 out of 100, leaving 20. And then we can go, we can do a 4 and 20 and 5. And then we have to break down anything that isn't prime. We have to break it down into primes. And you'll always be able to factor down into primes because primes can be multiplied together to create any other number. And then we just have to take all these and let's write them in order. We have 1, 2, 3 2s, 1, 2, 3 5s, and that's it for the prime numbers here, right? 2, 5, 5, 5, 5, 2, 2. So 2 cubed, 5 cubed. So we've got, this is going to be long, but 2 times 2 times 2 times 5 times 5 times 5. Okay? So we wrote the equivalents there, and now we're going to do our little game of Go Fish. Cross out the matching numbers. So we've got a 5 here, right? Cross out the 5. Do you have any 5s? Yes. Do you have another 5? Yes. So the 5s are all gone now, and we're left with a 3. In the numerator, we have a 3, and in the denominator, we have 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we can use prime factorization to reduce 375 thousandths to 3/8. So it shows they are the same. These are just representations of the same number. One is rational and one is decimal. Okay, awesome. Let's take a look at the next one. This one might be a little more interesting. 11 divided by 16. This is sort of the fraction we're looking at here. Write this as a decimal. So we're going to have 11 in the box. And we're going to be dividing 16 into that. 16 won't go into 11, so we're going to have to do the same strategy. Put a decimal point there and one above on the line, and then add a few zeros. Okay, doesn't matter, they're free. So 16 won't go into 1. You know, if you wanted, you could put a 0 there. Doesn't matter. These are called leading zeros, and out here we have trailing zeros. 16 won't go into 11, so 0 there too. And then 16 will divide into 110. We look at these next 3 numbers. So how many times will 16 go into 110? It's a little bit harder. You have to kind of guess. So 10 times 16 would be 160, which is like 5 times too much. So 3 times 16 is 48, which will bring us almost down close enough. So I'm guessing maybe 6. We're down 4 places from 10. Let's try 6. 6 times 6 is 36. Let's put a 6 here and carry the 3. 6 times 1 is 6 plus 3 more is 9. That put us pretty close, 96 from 110. All right, let's subtract and see what we have. Borrow 1 from this 1, leaving 0 and giving us 10 here. 10 minus 6 is 4. And then borrow 1 from this 1, leaving 0 and giving us 10 there. 10 minus 9 is 1. So we have 14 here. And we're going to bring down the next number, which is a 0. And then we can move forward. How many times will 16 go into 140? Well, we just saw that 10 times 16 would be 160, which is 20 too many. So we need to go 2 less than that, which would be 8. Let's try 8. 8 times 6 is 48. Carry the 4. 8 times 1 is 8 plus 4 more is 20, 128. And then let's subtract it. Borrow 1 from the 4, leaving 3. 10 minus 8 is 2. 3 minus 2 is 1, and 1 minus 1 is 0. So we're left with 12. And we bring down our next 0, 120. And how many times will 16 go into 120? Well, 8 times 16 was 128. So if we do 1 less than 8, it should fit. So let's try 7. 7 times 6 is 42. Carry the 4. 7 times 1 is 7 plus 4 more is 11. And let's subtract this out. 0 minus 2 we can't do, so we borrow 1 from the 2, leaving 1, making 10. 10 minus 2 is 8. And then we have zeros, 1 minus 1 and 1 minus 1. So all zeros after that. And I didn't add another 0 for this, but I can because it's free. And it doesn't change the value of the original number. It just allows us to be more precise. So let me move that up again above that line. So how many times will 16 go into 80? And if you know my multiplication by 5 rule, you can turn that on its head and realize that 16 will go into 80 5 times. So we'll put a 5 here. 5 times 16, so multiplication by 5, take half of this number and add a 0. Half of 16 is 8, and add a 0, that's 80. And we have 0 remainder. And our decimal here is 0.6875. So 0.6875, which is also read 6,875 10,000ths. So that's a mouthful, but we could write this as a fraction as 6,875 over 10,000. It's quite a big fraction, so you would want to reduce it, which you could do using prime factorization, and you could reduce that right back down to 11 over 16. But the answer they want at WAMAP is here. Let's go ahead and plug these in, see how we did. If we can find them again. There we go. Right 3/8 as a decimal. So this box looks a little bit small, but it was 0.375. And that leading 0 you can use or not. You don't have to have it. And we got a green check there. And then 11/16. This was a bit harder. 0.6875. It's a nice big, so it doesn't even fit in the box. They could have made those boxes a little bit bigger, but let's see if we got it right. Okay. And you can go ahead and work a similar question, 9 over 4. Now this is an improper fraction, which could be interesting. And over here we have what? 13 over 16. Let's work the 9 over 4. And I'll try to keep this small so I can get a single screenshot. 9 over 4, right? 9 over 4. Let's get a new color. Let's go with purple. All right, so 9 over 4, we're going to divide 4 into 9. So that's an improper fraction, so it will show slightly differently. I'm going to go ahead and put a decimal place here and some zeros. And then we're going to say how many times will 4 go into 9? Okay, this time it does go into 9 twice. 2 times 4 is 8. Subtract that from the 9 to get 1, and then bring down one of our added zeros. 4 goes into 10 how many times? Also twice. 2 times 4 is 8. From 10 leaves 2, but we can borrow 1 from here, leaving 0, make that a 10. Got a 2. We're going to bring down the 0 to make 20. How many times will 4 go into 20? 5, you say? That's right. 5 times 4 is 20. 0 remainder. So this improper fraction becomes 2.25. And if we were to convert this improper fraction into a mixed number, it would be very similar to this. We would divide 4 into 9, you get 2. And then 2 times 4 is 8. Subtract that, and you have 1 left over. So that would be 2 and 1/4, right? That would become 2 and 1/4, which is 2.25. So these all three are this, they're saying the same thing. And so this is something to keep in mind. that 2 1/4 is the same as 9/4, which is the same as 2.25, or 2 25 hundredths. So all of the fractions that you write as decimals where the numerator is smaller than the denominator will have a 0 here in the first place, because they're less than a whole, less than one whole. But if you have if your numerator is larger, you're going to have a whole number here on the left, and then the rest of the decimal. Okay, so if you have questions about that, please contact me. Otherwise, give this a try, and yeah, message me if you get into trouble.